by column, stick it in a matrix, and you'll see what works. This 3x3s, whenever they're the same, this is called a square matrix. 2x2. We do special things with those down the line. I asked you to do, did I ask you to do one REF? One REF? Just so that you see the difference. Why would anybody want to do this? Beats me, because our REF is so much simpler. But there might be times when we have no solutions or all solutions that we might need to do this and work it backwards. Start with this. You'll notice that these are not zeros. This is how you notice this is REF instead of RR. This is not a zero. Normally it would look like this. God bless you. But notice this is not a zero. God bless you. So in this case, you're going to start here and you're just going to work yourself backwards and solve. I'm sure there's good cases for it. RREF is just easier. This tells us there's no solution. God bless you. We have an X and a Y. An X and a Y. So if you did REF, you can't really work this backwards. You don't have a Y equals anything. There's no Y equals. If you did RREF, you're going to see the same thing. It doesn't go across. I think I did REF, but I told you guys you could do RREF. You know what happened? When I took it at book last year, I probably just told the kids rather than put it in the directions. But RREF is fine with this. I'm fine with RREF. This is just back substitution to do REF. But you guys just had to do RR. Just put it in your calc and get used to that. Good. It should work out the same answers, does it? For you guys? Alright. Do this. Today we'll do some basic matrices. Some operations. Yeah, make sure you have calc, because we're going to be putting this in your calculator. Alrighty, so let's go through this. Just different operations. The only one that's probably going to give you problems is the multiply. And the multiply is the only one that we ask you to do by hand. What am I missing? Oh, I'm sorry. All right. Okay. Ready? God bless you. All right. Two matrices are equal. This is if and only if. This condition has to be met. Their corresponding entries are equal, not the entries themselves, but the positions. So the orders have to be the same. So if this is a 2 by 3, this is a 2 by 3. All you're doing is placing, God bless you, like one on top of the other and adding their parts. So 0 plus 1 gives us 1. 1 plus 0 gives us 1. Negative 2 plus 3 gives us 1. 1 plus negative 1 gives us a 0. 2 plus 2, 4. And 3 plus 1, 4. And we show a matrix like this with the little brackets. Okay. Now, in your calculator works really, really nicely to add these guys. But they just have to be in the same order. Because say if this had another row here, we'd be missing that. What would we add to that? So they have to be matching. Not the entries themselves, but the positions. Now in your calculator, an easy way to do this is put it in matrix A. Let's go through just a couple of these so that you get used to this. To get to A, just go to edit, click on A. So this is a 2 by 3. And we just put the positions in. Okay, don't forget to click. And then to get to B, we'll do another one. Just go in here, go to edit first, and then come down to B. This is when you kind of want to leave them in there. And you have the same thing, a 2 by 3. So you put in B's. Do it with me, guys. You guys do it too. This way it comes easier to you. And I'm sure your calculator works a whole lot better than this calculator. Okay, so now all you have to do is this. Click on matrix A, put a plus sign, and click on matrix B. Come down to B, click on it, so that it says I'm adding these two together, and enter. And then it gives you your result. And we should get this result. See it? If I want to subtract is nice because a subtract says this. 0 minus 1, negative 1. 1 minus 0, 1. Negative 2 minus 3 is what? Negative 5. 1 minus the negative 1 is what? 2. 2 minus 2. And 3 minus 1, 2. So, and again, if we do this, all we have to do is this. Take our matrices that are in there and just change this to a minus. And you get your new matrix. Okay. Multiplying is different, and we can't divide them. The problem with dividing is the zeros. Because you can't divide by 0, it won't do divide for you. It doesn't even know that you don't have zeros in them, but it won't do a divide. And in multiply, we have a different situation, but we can do any of this. We can also do this. If I want to make this equation, this is called the scalar operation. I'm going to do it all up here since it's just easier to have them in your calc. This is called the scalar, when you multiply by one number. That means I take this and I multiply every entry by 3. So 0, 3, negative 6, 3, 6, 9. So all I have to do in my calc is this. 3 times matrix A. 3 times A. And it gives me my matrix. If I want to do 3A plus 3B, all I do is this. 3 plus, 3b. Any of my work here. Well, I think it's going to just work better in yours. There it goes. 3b. All you have to do is this. So it'll multiply both of them by a scalar 3, and then it will follow order of operations and add them together. Piece of cake. This works nicely with your calculators. And again, you have a number of matrix things. You can do them for a long, for a while. This guy, this is 2 by 3. This is a 3 by 2. If you went to try to add them, you would look for 2 plus 1, 1 plus 1, but there's no 0 corresponding here. So this one is undefined. We cannot do this. If you put it in your calculator and you try to add them, I think it also gives you undefined, or it gives you something like a weird answer. They have to be the same order to be able to add them. I can still do this. I can multiply by a scalar for any of them, but I can't add them unless they're in the same order. Got it? It's easy.
First, you minus the type, right?
Mm-hmm.
You, like, say you just want to do that to A, can you just do it to A, or do you have to do it to A?
Nope, you could do it to A. Whatever it is you want, it's in your A matrix. You could do it. You could take a half of it. If you have a matrix in A, your matrix is A here. Even though you listed them out, you don't have to use them. You only need to use the ones that you want. So say you want to take 3 times A. Say you want to take half of B. All you have to do, wait, give me 1 second, guys, is just do this. 0.5 times B. Whatever it is you want to do, you just go in and do. It'll take half of B and give you the answer. And again, if you want to put it in fractions, hit math, enter, enter. And it'll flip it to a fraction. Question? Oh, I thought someone had to know. Okay. All right. Scalar multiplication is the only one that's going to be a little bit different. Now, scalar multiplication, oh no, that's the one we just did. I just did this, so I'm not going to do that again, because we already had your matrix in. You can solve equations using your matrices, just as you do in algebra. If you solve for x, you just isolate x, so you're going to subtract a. These are matrices when we call them by the big letters, the capital letters. That's how we call your matrix. So we call it with a capital letter, and we just divide by 3. So it might be easier is just pulling out the 1/3. So you put in your matrix A, put in your matrix B, and then you put this in your calculator. It works very nicely. I wouldn't do them by hand. You have your calculator to do all these. You can absolutely do this if you like. B minus A means you have to subtract this way. Then that answer you're going to take 1/3 of before you build your matrix. So let your calculator do it. Most of these are not so bad. Are they making sense to you? Making sense? Stop me if they're not.
So when you put that into the calculator, you put in your matrix, and then you do the 1/3 parentheses.
You do just that. Exactly. 1/3. Not always so easy for mine.
Your finger like down.
I think it's this side of the board. And then you would just do that, pull up your matrix. And say B. Just make sure you get it in the right order. Minus. And pull up your matrix again. A. And definitely flip this to a fraction. Okay? As long as you can use your calc, use your calc. The only one that you're not going to be able to use your calc for is the multiplication one.
How do you flip it to fraction?
Just hit math, enter, enter. You're at math, it says fraction to fraction. Okay. Ready for a product? This is the only one that's going to give you grief. Not really grief, but you have to do this. You have to be able to do this by hand. Okay. But in multiplication, we have a rule first. In order to see if they are going to multiply, you take their order. So this is 3 rows by 2 columns. This is 2 rows by 2 columns. The inside 2 have to be the same. Those have to be the same to multiply. The resulting matrix, this is your result. This has to be the same. This is your result. So we're going to build a 3 by 2 matrix. If these aren't the same in the middle, undefined. We can't multiply them. And yes, you could still put them into your calculator. You could still do a multiply in between, but we need you to be able to multiply this out. So if you just watch first, and then we'll do another one together. We multiply this way. Once we know this works, we say this row by this column, and we multiply the corresponding entries. So -1 times -3. I'm going to write them out because I want you to see the pattern. Then you do the second one and the second one, plus 3 times -4. Good. Now I take this guy, I do the next one. Make a little mark here. The next one, -1 times 2. Corresponding entries, plus 3 times 1. Okay, so we exhausted that row. Next one, next row. First column. The most important thing is just remember, it's row by column, same as your order. So we start here, 4 times -3, plus -2 times -4. Because I'll show you at the end. It doesn't make sense yet until we get this whole grid done. Then we do the next column with this row. 4 corresponding entries. 4 times 2 plus -2 times 1. And we'll see a pattern going on here, right? Okay. Last row. First column. 5 times -3 plus 0 times -4. Last column. It's always row times column until the columns are all exhausted. Okay, last one. 5 times 2 plus 0 times 1. And we're done. Now, does this give me 3 rows? But I get a whole lot of columns, right? But I broke it after I did the first row times column, right? So this section and this section give me 2 columns. I have to add these pieces along here, which is why we put the plus sign here. But watch the pattern first. This is how you know that you did it right. Look at where these numbers came from. -1, 4, 5. Look where these numbers came from. 3, -2, 0. Look at these guys. All -3s. All -4s. All 2s. All 1s. See the pattern? If you struggle with multiplying at all, write it out this way. I still write it out this way. Some kids try to multiply and then add them in your head, then you can't see if you made a mistake. And if you checked it in your calculator and you made a mistake, you're forced to go back and do the whole part over instead of look to see if it's wrong. So what we do now is just add these together, and you can string this part in your calculator or work it out by hand. -1 times -3 is 3, plus a -12 This gives me -9. This gives me -2 plus 3. This gives me 1. 3 rows, 2 columns. -12 plus +8 gives me a -4. 8 plus a -2 gives me 6. See what I'm doing? Just adding the pieces up. -15 plus 0 gives me -15. 10 plus 0 gives me 10. There's my resulting matrix. Now, you can always put this in your A and your B and just do a multiply on it. It will come out and look like this. And for some odd reason, one of the things we require is for you to be able to multiply this out. We don't go any further with it in precalc than just multiplying out and coming up with it. We also, on an inverse, on a determinant, we do a basic 2 by 2, but in college, sometimes they do them a little bit more. So, if you're forced looking at this in college, at least you'll know where this comes from. We'll do one together, okay? Everybody get the pattern? Row, column, row, next column. If I had more, row, next column. I would just keep on going with that row till I exhausted all the columns. Then I go to the next row, and I keep doing it again. Let's try one together. Okay, next one. All right, do the order first. What's this order? What, I'm sorry? 2 by 3, 3 by 2. Row, columns. How's this guy? So we check the inside ones. Do they match? Yes. What's my resulting matrix going to be? 2 by 3. This is going to be my resulting matrix, a 2 by 3. 2 rows, 3 columns. So we start. First row, first column. I'm going to write it out again. 1 times -2. Because if I don't write it out and you go home and you just edit them in your head, you don't see where they come from. Plus, we just put pluses in between. Corresponding entries. 0 times 1. 3 times -1. And once you reach the end of that, just make a little break. I gotta fit 3 of these in here, so I gotta write smaller. Okay? Next column with this row. Okay? 1 times 4 plus 0 times 0 plus 3 times 1. We exhausted that column. Take a break. Last one. Everybody following me? Okay, it's not bad, it's just a pattern. And I always get a couple of kids that say, do I have to do it this way? And I say, no, you don't. You don't have to do it this way. But as soon as they make a mistake, they're like, I don't know where I made my mistake. Like, yeah, it's hard once you don't know where you make your mistake. You're not going to have to do too many of these anyway, so. Next row, last row, first column. 2 times -2. That's -1 times 1. Plus -2 times -1. This way you get to see, do they line up? You see it right here before you even start adding them. Next column. 2 times 4. That's -1 times 0. Plus -2 times 1. And then the last one. 2 times 2. -1 times 0. Plus -2 times -1. And we're done. And all you have to do is add up your pieces. You need 2 rows. This is 1 row. This is 1 row. You need 3 columns. 1, 2, 3. If you want to, just string this little piece in your calculator even. So this gives us negative 2 plus 0 plus negative 3. So what do we get? Negative 5. This gives us negative 4, negative 1, 2, negative 3. This will give us 4 plus 0 plus 3. This will give us 8 plus 0 plus negative 2. And last, this gives us 2 plus 2, 4. This gives us 4 plus 2, 6. Did we get that? Whoops. Nope. 2.
Isn't the one on the right supposed to be 3 times? Yeah, 3 times.
I made a mistake right here.
Yeah, it's this. It's 3 times negative 1.
In the top.
It's 3. Thank you.
No,
Nope, not this one.
Negatives.
My ones are good.
Negatives.
Like the very last one, it's supposed to be negative 3.
It's supposed to be a 3. Just a plain old 3.
Yeah.
Or 3 times.
And this is good. See how we did this? This way you can see your pattern here. My pattern should say I should see 3 and negative 2. I saw a 2 and a negative 2. My mistake. So makes life so much easier to find. And so this guy should be, oh, let me move this out. Just move him over. This guy should be a negative 1. Not bad, right? A little annoying, but not too bad. And that's that. You guys have any questions? No? All right. On your homework, take a look at your homework for a second.